Alright guys, so this is going to be the final video here, and you're going to see me go through this one pretty quickly. This one's telling me to solve the inequality, so this is going to be one that you guys did very well on. And so remember, first thing is to find critical point, so I put whatever's in the parentheses, so x plus 1 equals 0, so x is negative 1. X minus 2 equals 0, so x equals positive 2, and x plus 3 equals 0, so x equals negative 3. And so since I have an equal sign, and this is a polynomial, these are going to be closed dots. So here at negative 3, put a closed dot. At negative 1, put a closed dot. And at positive 2, put a closed dot. Okay. So now I have to test points, one that's smaller than negative 3, one that's in between negative 3 and negative 1, one that's between negative 1 and 2, and one that's bigger than 2. And so that's what you're going to see me do right here. Again, I'm not going to go through every single one of these because it does take a little while to get through, and you guys know it does. So, looking here, something that's smaller than negative 3 is negative 4. And I went ahead and did the numbers here. So I found that 54 is either greater than or equal to 0. That's true, so put a check mark there. Something in between negative 3 and negative 1 is negative 2. And that's what I did right here. So I found that negative 4 greater than or equal to 0. That's not true, so that's an X. When I plug in something between negative 1 and 2, like a 0, I found that negative 6 is not greater than 0, so I put an X there. And something bigger than 2 is 3. And I found that 0 is greater than or equal to 0, so I put a check mark there. So final answer, so I'm going to come back to the paper here, is, since I had a check mark here, an X here, an X here, and a check mark here, is negative infinity to negative 3, and I use a bracket because it's a closed circle, and then I don't have check marks until 2 to infinity. So that's the final answer there. Okay, so next problem here is pretty much the same thing, and so now this is just a rational, and this is going to be one of the easier ones because I don't have the equal sign under here. So these are all going to be open dots when I find the critical point. So first one is x plus 3 equals 0. So at negative 3, 2x plus 1 equals 0, which is this one right here from the denominator. So minus 1, 2x equals negative 1, and then divide by 2. X equals negative 1/2. And x minus 1 equals 0, so x is equal to positive 1. So those are my three critical points, and you can see I already put them here. All open dots because of there's no equal sign under the 0. And again, I did the math here. I'm not going to go through every one of these again. You can pause the video. My points that I used were something smaller, negative 3 is negative 4. Something between negative 3 and negative 2 is negative 2. Excuse me, negative 1/2 is negative 2. So that's what I used here. And something between negative 1/2 and 1 is 0. So that's what this is right here. Something bigger than 1 is 2. So you can see right here. And I had check mark X, check mark X. So again, just choose your numbers, go through them on your own. You'll see that you'll have these results, okay? And looking at those, I had check mark X, check mark X. So final answer here would be I went from, excuse me, this should be parenthesis, negative infinity to negative 3, because it's an open circle. It's going to be a parenthesis. And then negative 1/2 to positive 1. Okay. So this is going to be the big one, okay? So this one's probably going to be worth the most points. Again, go ahead and change this. You should already have changed it in class because I gave you the instructions to make this x cubed plus 4x squared plus 3x divided by 4x squared plus 8x, okay? And when I do that, the factored form looks like this, okay? And so here, they're not going to ask you in order the way I've been showing you in class. You need to pay attention to what they are asking you for. So if they ask you for holes or discontinuities, guys, remember, here I do have a hole because I have an x on top and x on the bottom, and they will cancel each other. So I have one at x equals 0, a hole, okay? Next step is to find any asymptotes, okay? That's how they'll ask you. So it doesn't necessarily have to be in the order that I told you, but I can find asymptotes, guys. You already know. The horizontal and the slant asymptote, I look at the power, which is here I have a 3 and here I have a 2. So since the n is greater than the m, I have a slant asymptote, okay? And I have no horizontal asymptote. So if you happen to have a slant asymptote, you have, and they ask you for the horizontal, tell them you have no horizontal, okay? Because you have a slant. You can have one or the other, not both. So I have to do the long division, okay? And I know that you guys had a little bit of problems with these. So again, guys, what's in front is a 1, and use the not factored form. So this one right here. So 1 divided by 4 is 1/4 x. Okay, and then these should cancel. So again, if I want to do 1/4 times 4, you can think of it like this. So it's just 4 divided by 4, which is 1. That's how I got the 1x cubed. And then you move on, 1/4 times 8, so it's 8 times 1/4, which is 8 divided by 4, which equals 2. So that's where I got this 2x. And again, you have to change the sign, so this becomes negative and negative. And 4 minus 2 is 2x. And you do this process again. So 2 divided by 4 is 2, so 2/4. And so you can stop there. I really don't care about the rest. It's just a remainder. My slant asymptote is y is equal to 1/4 x plus 1/2. Okay. Vertical asymptotes, these come from the denominator. So since we had already scratched out the x here, all I'm left with is x plus 2. You set it equal to 0, so x is equal to -2. Okay. Again, this is the vertical asymptote. Move forward, guys. My x-intercepts, these come from the numerator. So again, I had already canceled the x, so I'm left with x plus 1 and x plus 3, so I get 1 at -1 and at -3. And the y-intercepts, guys, with whatever's left, so I'm using this equation right here, but with the x is already canceled. Plugged in a 0 for x, and I found that I have a y-intercept at 3/8. So when I go to graph this thing, okay, I already know that I had a slant asymptote at y equals 1/4 x plus 1/2. So 1/2 is about right here, and I go up 1 and 4 to the side. Up 1 and 4 to the side. So something that looks like this. Then I had the asymptote vertically at -2, so 1 right here. My intercepts were at -1, so 1 right here, and at -3, so right here, and a y-intercept at 3/8, which is like about right here. Okay, so I know that this graph looks like this. Remember, it's going to come close to the asymptote, but not really touch it. And it has to go through those points. So this is the way my graph looks. And since I had a hole at 0, guys, right here, this is x equals 0, you just draw like a big open dot there. That's a hole. Okay, so concentrate on this problem, guys. This is going to be the one that's probably worth the most points. Okay, so final problem here. We kind of already did one like this, so I'm just going to go through this real quick. Just so part A is like looking at this graph, how do we know there's only one real solution? So guys, I mean, I can see here on the graph, it only crossed once. So I only have one real solution. That's what that means. And since this is cubed to the 3rd power, I should have 3 answers, but I only have 1 because it's right there. So that means the other 2 are imaginary numbers. Okay, so we're going to move forward here. From the graph, it appears we only have one solution. So we saw it only crossed the x-axis at x equals 1. And because it only crossed at x equals 1, that's why I know I only have one solution. So how can I verify algebraically? So if it says algebraically, guys, how can I verify? Remember, that's where my x equals 0. So if I plug in a 1 to my equation, it should equal 0. Okay, so 1 cubed is 1. 1 squared is 1, so this becomes 3 times 1 plus 1 minus 5. So here, 1 plus 3 times 1 is 3 plus 1. Excuse me, 1 plus, my mistake. 3 times 1 is 3, and 1 plus 3 is 4 plus 1 minus 5. So 4 plus 1 is 5, and then minus 5 equals 0. So here I can see since it equals 0, that is a solution. Okay? So here, now they're asking what are all the solutions, guys. Now I have to do the synthetic division. So I saw that it crossed the x-axis at 1. So I'm going to do my synthetic division. So I see that this is a0, which I already proved over here. So this becomes x minus 1 times x squared plus 4x plus 5. Okay. And since I want to know the rest of the solution, remember I should have 3 because it's to the power of 3. I know the other ones are imaginary ones, so I have to do my a, b, and c thing to find the imaginary roots. So 1, 4, and 5. Again, my equation is negative b plus or minus b squared minus 4ac over 2a. Okay, I went ahead and did the math here so you guys can see. And once I do that, I find that my solution here is 4 plus or minus I square root of 4 divided by 2. So if you leave it like that, guys, that is fine. Remember, if you have a negative inside the square root sign, you cannot. So that's when you turn it into an I and it comes out. Okay, so I have my solutions. I have positive 1, 4 plus or minus I square root of 4 over 2, and 4 plus or minus I, oh, excuse me, this should be a plus only, and this should be a minus only. Okay, and if I want to write this in terms of linear factors, this would just be x minus 1. So remember, you change the sign. X minus, and then you just put this one in one big parenthesis. You just leave it like that. X minus again, but now instead of putting a plus sign, you put the minus. And that would be your answer in linear form. So again, guys, this part right here, writing it like that, we didn't go over in class, but we did do this, okay? And so it's just one extra thing. So study hard, ask me questions, and again, we are testing on Tuesday.